Hello everyone, today we're going to be talking about section 4.4, which deals with translations. Now translations is a new type of transformation. In order to do it, we need to talk about these things called a composite. Now a composite uses a symbol like this. It is an open circle. You see it right down here between these two R's as well. That open circle means I'm composing T with S. So this is going to be the composite of first transformation S, then T. And this will map, or it maps each point P onto the transformation T of S of P. And that notation gets a little bit clunky there, but really what this is saying is that I have two transformations. I need to do them in some order. But the first one that I do is actually the inside one, or it's the one that comes last. So I do S first, or I do S on the inside here on P. Then I take whatever I get from that, and I do the transformation T. I do not go back to the original picture. I use the new picture that I got after the first transformation to do the second. What that's going to look like for us is mostly this notation that's down here. Usually it's reflections because we're reflecting over our lines. So in this case, I'm reflecting the triangle ABC. Now I would actually reflect over the line N first, then M. So I would say N first, then M. Alright, just based on the order of these. I start on the inside and work my way out. Okay? And that gets us to a translation. A translation is actually an example of one of these composites. It is the composite of two reflections over parallel lines. And they do need to be parallel lines. If they're not parallel, then we get something different. So those parallel lines. And when we talk about a translation, we're talking about sliding a figure. So I take something, and then wherever it's at, I literally just take it and I move it over somewhere else. So I'm just sliding that shape. Now when I slide it, because this is based on reflections, all of the same properties are preserved that were preserved during just one reflection, okay? And those were our ABCDs. So that's angle measures, betweenness, collinearity, and distance. And then in addition to that, we got to think about orientation. Now we know orientation switched during one reflection, but because I do two of them, the first reflection will reverse the orientation. The second reflection reverses it again or brings it back to the original. So in this case, in the overall transformation, orientation is preserved. And so for our properties here, we actually say this is A, B, C, D plus O. And we actually get that extra orientation. And now when we talk about our translation, we need to talk about two things. We need to talk about the direction that we move and the magnitude, which is how far we move. Well, the direction is going to be given by any ray that goes from the pre-image to the image. Basically, I'm going from where I start to where I end, drawing the ray. That's your direction. The magnitude's a little bit trickier. We say that the magnitude is going to be twice the distance between the parallel lines, and that gives the distance between the pre-image and the image, which is what we're trying to actually do. Okay? Now the Two Reflections Theorem says that if M is parallel to N, then the translation over N, the reflection over M and the reflection over N, but we would do N first, has the following property. So it has a magnitude of twice the distance between the lines between M and N, which are my two lines, in the direction of a ray perpendicular to M and N, starting at the first line of reflection, which in this case is N, so starting at N, going toward M. Okay, so we're starting at N and going towards M. Well, in this example, I have this kind of picture down here. If I was using this reflection that I just had here, which is the reflection over n and then over m, I would know that I need to move perpendicular from n to m on that angle, so on that direction. That amount is 3.3 centimeters. Okay, I've already measured it on a different paper here, but you could take your ruler and actually measure that. It should be about 3.3 centimeters. Okay, and then I take that distance, and I need to move each of these points double that distance. So I would move each of them 6.6 centimeters down to this lower left direction. And so I'm not going to do it or take the time to actually show you, but all of these points would kind of end up over here-ish, kind of down in that bottom corner, because I move them all those 6.6 centimeters from where they start. Okay, and that would actually end up there. Okay, I'm not going to show you that because what I actually want you to be doing is doing this with a mirror, which is what we're going to do with the practice problem on the back here. Okay, so for this one in figure M, or in the figure below, M is parallel to N, which is what I need to get a translation. Here, though, I've switched my order. So I'm going to go over M first and then over N. So to do my reflection here, I'm going to put my mirror on my first line, which in this case is M. So you can kind of see right along that line of reflection there. So I'm looking through, in this case, my left-hand side. I got my bevel side towards me. My points are on my side. I'm going to reach around and put just the points in the corners for A, B, and C. Okay, and so that's where they all end up. Then from there, I'm going to go ahead and flip this around. Now that point C almost is on the line. So I'm going to get as close as I can on that other side and put it right there. It's that point C. Then I'm going to spin this around again so that my points are on the same side of me. Bevel side is towards me. And I'll get my new A and B points on there as well. Okay, which again is just looking through my mirror to find where those points are. Well, now I need to go ahead and connect these. So I need to connect my points in the same way they were connected before, which for a triangle just means all 3 points are connected. But if it was a quadrilateral of some kind, make sure you connect the correct points together so you don't get a new shape. It's the same shape you started with. And when I go ahead and connect those all, I get that new triangle. And if you look, that looks like almost the exact same triangle. I should label these. I am going to label them with double primes. And the reason for that is I actually had to do two reflections. So these points that are here in the middle are actually my single primes, even though I didn't mark them. I don't know if they're C prime. But I'm not actually going to connect those because I'm not concerned about that shape. In fact, I really just need to kind of ignore that. I'm looking from the original shape to this shape as my translation. I'm sliding it up into the right there. Okay, so that is our translation, and that is going to finish this video. We'll see you in our next one.